The main purpose of the combiner is to reduce the network bandwidth between the map and reduce. What is that? So instead of sending all the key value pairs from your mapper, all the key value pair from your mapper to a reducer, what we will do local aggregation on each mapper. How it is on each mapper? It's pretty simple to understand. Let's say as we taken yesterday, an example is year and weather, correct?
Yeah.
We have taken something like this, right? So when my mapper is processing this data, my mapper also emits year and temperature, year and temperature, year and temperature, correct? So all these key values will go to a reducer. I mean, before reducer, it will go to shuffle and sort, where the grouping will happen. So when the grouping will happen such a way that it will go such a way that say 2000 as a key and group of values, correct? Like 23 and 45 and
I can
20.
see your desktop.
Oh, is it okay? Let me start sharing it. So this is the data set we have taken as an example, right? So this, when the mapper is processing, all these key value pairs will go to as emit as output from the mapper, and all these key value pairs will go to reducer, correct? Yes or no, guys? Yes or no? Your mapper output will be key and value, key and temperature, I mean year and temperature. So what will happen, all this key value pair has to go to reducer. So before going to reducer, that will go to as a shuffle and sort. Let's say I'm taking 2000 here, 2000 has a 23, 45, 20, 20. These are the combination it has collection. Next take, if you take 2001, and what the key value pair, it will go here, it will go 2001. If you take 34, 10, 56, like this it will go. Yes or no? It means each mapper is passing few set of key value pairs from here. So instead of passing all these values 23, 45 to a reducer, what we will do using combiner, you pass 2000 has 45 is the maximum temperature. 2001 has 2001 has 56 is the maximum temperature. So we will not send all the values. Okay, we will aggregate locally, then we will send a less number of values to your reducer. Yes, there may be a chance the mapper 2 also can do the same, correct? Then the less number of key value pairs are going to your reducer. So by using combiner we'll do it. So how to do it and how it will help and all, we will look at it. So one second, let me connect my this pen pad, then we'll see that. Okay. As I said yesterday, combiner does not have its own parent class. Combiner does not have any default combiner. There is no default combiner. So combiner will extends a reducer. Combiner will extends reducer, and also it expects whatever the input you are sending to a combiner reducer, the same input has to go to a combiner. The K2 V2 will go to a combiner first, and the K3 V3, actually if you have a combiner, it will be processed and the same type of key value will go to a reducer. If you look at here, it's taking K2 V2, and in the reduce method, because it does not have its own parent class, and it is extending a reducer class, and it is overriding a reduce method. It is overriding reduce method, right? So and you are writing your logic here. You can write whatever the logic. So it's not a constant logic. You can write any logic here. So based on your use case, right? So what does it mean? Combiner also will run on reducer slot. So there is no slot concept now in Hadoop 2, but before how it was working. So each machine, each data node will be having two type of slots. I mean two type of processors. And each slot, let's say one slot is for mapper, one slot is for reducer. Those are reserved. Those are reserved. In Hadoop 1 I'm talking about, guys. I'm just giving you an idea. In the Hadoop 1, it was like it is reserved. So the map will launch only in the map slot. Reduce will launch in reduce slot. Understand? Map will launch in the map slot only. Reduce used to slot run in the reduce slot only. So a combiner also will be executing in reduce slot only before in the Hadoop 1 version, but Hadoop 2 there is no that kind of concept. But still, if you have a reducer, then only your combiner will work. Let's say your job you have specified number of reduce tasks are 0, but there is no combiner will launch. No combiner will launch. If you in the reduce in the driver class, you have to specify here number of reduced tasks. If you specify number of reduced tasks as 0, no combiner will work. If you say number of reduced tasks at 0, no combiner will work. The map output itself is the final output. Okay, and and if you are writing your own combiner class, if you are writing your own combiner class, but if you want a combiner class, it means that if you want your combiner class, what you need to do here, you have to say job dot set combiner class. Job dot set combiner class, then only your job understands that there is a combiner class for this job. There is a combiner class for this job. Okay, so the details I have given a detailed explanation in this. If you go through this drive, in our drive, if you as I shown yesterday, that the whole details whatever I have explained, if you want to read out one more time, you have the same details in this notes. I would recommend you to go through once in the Mapreduce notes. This one. So with an example, with a detailed explanation, it is there here, and you can also find the similarities between the combiner and reducer. What is the what is the combiner versus the reducer? And so for the reduce, if you set the reducer class as a reducer class, the same way you will set the combiner class also. Okay, by default if you don't have any reducer, the default reducer will launch, but there is no default combiner. Okay, so your reducer obeys the data localization, means your reducer has to collect the data from the different mappers. The data will be moved towards your reducer slot or reducer machine, but in the combiner it is local. Wherever the mappers are launched, there only the combiner will be launched. Okay, and similarity is both runs in the same slot, which is reduce slot. If number of reduced tasks are 0, then both of them will not run. If number of reduced tasks are 0, combiner will not run, as well as your reducer also will not run, because number of reduced tasks are 0, right? So, and also your combiner will not be suitable for all the use cases. See, now we have taken use case as a maximum, right? So in this use case it will work, right? In that use case it will work. But let's say I want to take a average. I want to find out the average. So if it is find the local average, then a global average, so you will not get the proper output. So that's why is the combiner. While you are using combiner, you have to choose whether it is suit for my use case or not. And also combiner is not guarantee. Combiners is not guarantee whether it will launch or not. Okay, to launch a combiner, your maximum number of splits, these are called splits, spill files, not a splits, it is called spill files. We'll talk about the spill files in today only. So the number of spill files has to be more. So then only your combiner will be launched. Else, no, your combiner will not launch. Okay, is this clear, guys? Madhu, Akash. So what is the combiner? Do you guys understand what is a combiner? I hope Akash might be confused what is a combiner because he didn't join yesterday's class. Madhu, Srikant, Srini, Sunil.
That's clear, Viru.
It's clear, right? So let's talk about any doubts, Srinivas?
No, no problem. It's fine.
Okay, okay. So guys, I'm not running the programs because the source code is there with you. I want you to run it, and if you run it, if you face any problem, let me know. So why I'm looking to you guys execute the code and face the problem. If you face the problem, yes, you will learn something new. So I want you to run the program. That's why I'm not executing. That's why the initial basic programs I have run and execute and shown you how to run it. And then now code is ready and the logic is ready. And you just need to do one thing. You just need to modify your logic according to your use case and run them. It's a pretty simple run. So, okay, you guys know it. Just create jar file, whatever the classes you want. I mean, we don't need multiple. Right click, export as a jar, then execute the jar file, right? So I want you guys to execute that and see the results. And also if you want to really look at whether the combiner is executing or not, I want you to keep on system.out.println in the combiner and try it. Okay, in your console, if the system.out.println is printed, it means your combiner is launched. That's the use case 1. Use case 2, in the driver class, you make it your reducer is 0. Number of reduced tasks are 0. Number of reduced tasks are 0 here. You say its number of reduced tasks are 0 and you launch with a combiner and check whether your combiner is launching or not. Okay, I want you guys to do this all these use cases. Okay, and if you face any problem, please let me know. Not at all problem. I can explain one more time. Why I'm leaving to you guys? Because I want you guys to learn something new. Okay, is that clear?
Okay.
Madhu, is that okay? Or you want me to execute the program? I can execute the program. It's a hardly one step, 1 or 2 steps.
No, we can execute the program, Viru.
Yeah, yeah, good. So the next one is the next one is we are going to talk about is circular buffer. What is a circular buffer? See, as we discussed before, each mapper 1, mapper 2, mapper 3, and so on, they will not directly write the output into disk. They will not write output directly into disk. Where your mapper output will go? Guys, where is your mapper output will go? Will it go to HDFS or local? Your mapper output
Local disk.
in the Mapreduce framework, your mapper output will go to local file system or Mapreduce HDFS.
Local memory. Then
Local
HDFS.
memory means local RAM or local hard disk,
Local hard.
Makes sense.
right?
Mapper output is the
Correct, right? So when you have a map and reduce, your output of mapper will go to local file system of each data node. Correct? Wherever the mapper is launched. Right? If you have a map only job, yes, your mapper output will go to HDFS only because there is no intermediate data. So if you have a map and reduce, there is intermediate data in middle data. Intermediate data is nothing but map output. If you map only job, there is no intermediate data. Whatever the data is you are emitting, that is intermediate data. Correct? Do you guys agree with me?
Yes.
If you have a map and reduce, the mapper output is an intermediate data. It means middle data, because before mapper, after mapper, and before reducer, there is something called some data that's called intermediate data. That is a mapper output. That mapper output will go to each machine wherever the mapper is launched, that local file system. If you have a map only job, there is no reducers. Reduce number of reduced tasks are 0. In that case, your mapper output will, final output will go to your HDFS. Your HDFS. Okay. Now there is something called circular buffer. As I said before, your mapper output directly will not directly write into hard disk. It will not directly write into hard disk. Each mapper will have their own memory called circular buffer. Their own memory called buffer memory. It will have their own buffer memory. Each mapper, it is for each mapper, guys. If you have a 3 mappers, 3 buffers. Each mapper will have their own buffer memory. What it is, what it will do. Your mapper will start writing key value pair into this buffer. Key value pair into this buffer, and this buffer has some size. There is something called mb.io.sort mb, io.sort.mb. I hope I forgot the configuration name. io.sort.mb equal to, by default it is 100 MB. By default it is 100 MB. Okay, I think io.sort.mb. I think it is map.io.sort.mb. So that's the default size of this is 100 MB. And there is something called threshold io.sort.sort. Threshold percentage, a threshold or percentage. Just so let me open the configuration file so make you very much clear about it. We can see that it's just not a very big problem. I mean, very big deal thing. We can see that. Yeah, if you see here, Mapreduce dot, that's what there's a old version, Hadoop one that was different. So Mapreduce dot task dot io dot sort dot mb is 100 MB by default. The total amount of buffer memory to use while sorting files in megabytes by default gives each a merge stream 1 MB, which should be minimized 6. Okay, it means it is telling that you have a 100 MB here, 100 MB size, and there is something called spill percentage. Map reduce dot map dot sort spill percentage is by default 80.80. It means 80% of the buffer. And here I was sort factor, it is like the number of streams to merge at one while. Let's say if you have a multiple sort files, I'll tell you that what is this, what is this 10 number also I'll explain you now. Okay, do you guys understand? These are the configurations. These are the configurations. These are the configuration. You can take them, you can keep it in our, you can keep it in our local also, not at all problem. You can keep it in local. You can keep it in our local. Okay, so anyway we are using the same. We are not going to modify anything. You can change, you can keep it. If you want to change it, you can change it. If you want to change it, change them, you can change them. Okay, let's look at now. So this buffer, what it will do, your mapper will start writing the key value pairs into this buffer memory. So this buffer memory size is 100 MB as shown in the configurations. So when it reaches to 80 percentage, there will be some different threads will start reading from the buffer, and they will start write into a disk. They'll start write into a disk or file. So I can say output file or disk. Okay. Normally it is a disk. So in the disk means it's a file in the file. So these files are called spill files. These files are called spill files. These files contains your spill files contains key value and partition ID. 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 Each key value will have in this partition spill file, right? Let's say this is spill file. Okay, let me take in this way. This is our spill file. Spill is nothing but 180% of the data has been spilled out. 80% of the data has been spilled out. So in this, I have a key value and partition ID. Partition ID means whether it has to go to reducer 1 or it has to go to reducer 2 based on the number of reducers. Next key value, next number. So like this, you will be having a data in this spill file. Okay, so these spill files will be internally sorts. Here only in the memory only it will sort based on the key value and partition ID. Key value, first it will sort on the key value, then it based on the partition. Let's say all partition, all 0 will come one place. So 0, 1, 2, 3 in the sorting order. Do you guys able to follow what I'm trying to explain?
Yes, sir.
Madhu, Srikanth, any doubt, please let me know. So I'll explain one more time. Akash, Srini, Madhu, are you there?
Yeah, I'm here. One quick question, Veerang.
Yeah, go ahead.
When 80% of that buffer has been filled in, right, in that memory, after that, I mean, the threads will write that 80% of the amount of data into this file, right?
Disk, correct.
So until then, it's keep writing. The mapper will keep writing into that buffer again.
Yes. Suppose your map logic is keep running. So there are two scenarios we need to understand. So there may be a chance where your map is completed your map output is filled only 70%. Let's assume that your map job is completed. So there is not required to spill out. So I can directly I can directly take the data from this buffer later for my what you called shorter shuffle phase. Okay. Suppose you, your mapper is keep emitting the output, but still you need some let's say your mapper may emit, let's assume that in this case 100 MB is the space, right? Let's say your mapper may send you 120 MB of data output as output. So in this case what will happen, 80% will be spilled out first spill file, and the second spill file will come as a 40 MB of data, right? Why this threshold they have taken, why this gap, 20% of the gap? Because your mapper may keep putting the data into buffer, it may keep putting into data. When it reaches to this, yes, other threads has to come and read. There is a space to your mapper to write. These are also threads, right? These are also different threads to write the data into buffer, right? So that's why the 20 MB of the space memory has been allocated for the to avoid the race condition. So suppose your mapper is completed 80% and there is no output emit from your mapper 1. Then fine, then no need to spill out. No need to spill out. So it's no need to spill out, it's no need to sort, it's directly right into hard disk. If it is going beyond 80% of the data, then only it will spill out in the different spill files. Understand, Madhu?
Yeah.
I hope it's clear, right?
Yeah.
So suppose if I have so many spill files, if I have 100 spill files, let's assume that. If I have 100 spill files, then all the spill files has to merge, right? Because they have to go to proper sort and shuffle, no? So this has given some spill files. This mapper 2 has given some spill files. Mapper 3 has given some spill files. Mapper 4 may give some spill files. All the spill files has to be merged, right? Right? When they are merging, your combiner will come into picture. Combining all the spills again, merging. While merging space also, your combiner will be launched when you have a more than 3 spill files. If you have a more than 3 spill files, your combiner will come into picture to combine the output of each mapper. Else no need, your combiner will not come into picture. Directly the data can be write into disk, after it can sort into later in the sort and shuffle phase. Okay, so what is this 10? What is this sort factor? What is this 10 here in the configuration file? This 10 is at a time, it will start merging 10 spill files at a time. 10 spill files at a time. It will start merging, packing. It will start packing 10 spill files at a time. That is a 10. You can change it. If you have 100 files, so 10 attempts. 0 to 10, I mean, 1 to 10, 10 to 20, 20 to 30, 30 to 40, like that. It will start attempting merging all of them. That is the 10. 10 files, 10 spill files will be merged at a time. Clear, guys, about this circular buffer?
Yes, sir.
So this merger, right, Vida,
Mm.
irrespective of the data available on different data nodes, it will take care of that one. If the spill files are available, suppose the mapper one is in one data node and mapper two is in data node two.
Mm. The
So
merge will,
this,
yeah, the merge will happen in the, that's what, it will copy all the data, then merge will happen. There
so
is
that
something
will happen in one more machine in the client machine or somewhere, or
where,
how that happens. Data is
where
available.
wherever your reducer is going to launch, right? Wherever, whichever the machine your reducer is going to launch, right? In that machine.
Okay, you mean to say this data will be transferred first into
Yeah.
those reducer
Yes.
machine, and then combiner will combine that, and then it will give you the map
In
sort and shuffle.
If it is in a single data node, if it is in a single data node, if you have a multiple spill files, it will merge in the data node wise, and it may have a multiple data nodes, right? All the global combining will happen at the wherever the your reducer is launched.
So yeah, I mean to say at any point the one data node will emit only one file.
It no need to, right? One data node may give multiple or one.
Multiple spill files, but as you mentioned, like the combiner will do the merging at the data node level, and it will emit the
Correct.
one file.
If you have a more spill files, if you have a more spill files, the combiner always will not launch. In one data node, you should have a more spill files. It's more than 3 spill files. It has to be there.
Mhm. Mhm.
I didn't get my point.
More than three spill files, I didn't get that point.
See, in single data node, you should have a more than 3 spill files. Like say, so this is a spilled one file, right? Now it is reached 80%. There may be in the same data node, there may be one more mapper might have launched.
Mhm.
Let's assume that these three are launching a single data node. Three mappers are launched
Mhm.
in a single data node. So all these three data nodes will launch three spill files, right?
Mhm.
So now here it will merge into single merge file. So that time your combiner will be launched. Suppose if you don't have a spill files in this data node, combiner will not launch. Let me show you that configuration. You will get very much clear understanding of it. There is something called forget the configuration much. Hmm, let's look at what is how many matches are there. Only two. That's a combiner. Mhm. Let me check. What is the configuration name? There is something, some configuration. Not how does, why this, no, that's not the one. Okay, I'll get to the configuration. Uh, I'll get to that configuration, Madhu. I forgot that thing. I'll get to the configuration, then I'll show you. So it is, it cannot, the combiner cannot launch until unless you have some, there is a configuration, the value has to match. The default value is 3. I do remember that is the default value is 3. I think spill files. Let me check the spill files. No, it's not the one. No, not this config. I'll get to that configuration, Madhu. Then I'll explain you in the detail about that. Okay. So that is how your mapper output will be written into buffer first. Then it'll go on sort phase there based on the keys and partition ID. Then it will spill out as a spill file. Now your spill file contain sorted keys and partition ID. If you have a more spill files, yes, your combiner will be launched and it will be process the data. If you don't have a more spill files within the data node, your combiner will not launch. Your combiner will not launch. That's why your combiner is not guaranteed to launch in all the play. I mean, combiner is not guaranteed to launch the execute your logic, whatever the logic is there in the combiner. It's not give guarantee. It is based on the data. So based on the how much data you are giving to your Mapreduce. Okay. So I'll get to the proper configuration. Then you can easily understand that. Any doubt apart from that?
Viral.
Yeah,
Yes. You told if it reaches 80%, then it will spill out and spill file will be created.
correct.
The example you have given, 100 MB will be there, 120 MB data will be there, but size is 100 MB.
Hmm.
So once it's reaches 80 MB, so 80 MB will be written into spill file. Then
Correct.
the buffer will be empty.
Correct.
And in the buffer rest 40% will be written, 40 MB will be written.
Mm,
So when we are taking output, we will take output from 80 MB from spill file and 40 MB from buffer,
correct.
or for 40 MB another spill file will create.
Okay. So anyway, once your mapper is completed, your whatever the data is there in your buffer, it no need to go to again a sort and sort. It's already sorted. So that will take it as another spill file. We'll take it as another spill file at the
Okay.
end of your map output. I mean, once your map task is completed. This spill
Okay.
file is created while your map is running because it is reached 80%.
Okay, but rest 40% when it is there, that time the buffer is not full. Now, how come another spill file is creating?
So because the other your map task is completed, no, your map task is
Okay,
completed. So then it has to take the data. For
okay,
this memory is for each mapper. This memory is not for the one data node. It is for each mapper. One data node you may have a multiple mappers.
that is correct. But if it is only 40 MB, if it is within the limit, then spill file is not creating. Directly from buffer we are taking.
Correct.
Okay.
See,
So
what are the
in
spilled
this
data
case, means
also, what are the spilled data also, it is going to sort and shuffle. Someone has to copy this, and if the spill is not happened, so it will be there in the buffer. The data again it will be written to disk. The data again directly write into disk.
yeah, yes.
Otherwise, otherwise your Redis will not copy the data to your what do you say for the shuffle and sort. That's called copy phase.
Yeah, that's what I'm telling. See, 80 MB will be written in the spill file, just 40 MB. That time buffer is empty. That time from directly we can take 40 MB and write into the disk. Why another spill file it is creating?
Okay, so now, let me understand your question correctly. So if it is when it reaches to 80 percentage, so it is spilled out into a disk, then a sort and shuffle. So the one spill file is created. So while spilling out
Yes.
it, so while spilling out, see, you need to understand one thing here. So when it reaches to 80 percentage, it will not spill out completely, then it will not write. It may write parallelly.
Okay.
Okay, it will happen. It will go as a
Okay.
parallel. Okay,
Okay.
so
Okay. Okay. I got it.
yeah.
Then parallel it will work.
It will go parallelly, right? So it is not does not mean that your memory will not say to mapper, hey, you hold on, I'll just write it and you hold on, then you'll start it. No, you understand, right?
Yeah. Yeah. Yes. 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 I got it.
Okay. Any other dots, guys? This is internals of your map. If anyone asks how it works, this is how it works. And for the more details, I also has kept one more file for you guys. That's called MR flow. There is a document called MR flow document. This document gives you detailed information from the map, your sort and shuffle, merging and reduce. Everything is given a detailed explanation. So anyway, I'll be taking through these guys because I'll be reading you for you and I'll be explaining each and every point from this document. Before that, I also want you guys to go through it once. I also want you guys to go through it once. Okay, you can also see here the part percentage by default it is. So I also want to go through this once. Then once we complete the rest of the topics, at the end I'm going to take you this because the end-to-end flow explanation, and there you will get a clear idea of when your mapper is launched, whenever his partition is launched, whenever his combine is launched. Or else what I'll do one thing. Anyway, we have completed the end-to-end flow. Tomorrow I'll take you through this document. Each and every point I'll be explaining from this document, and there if you have any doubts it will get clarified. All the things will be clarified, and the day after tomorrow we'll start the input formats. Okay, it will help you to understand what is my buffer size, what is the when the spill file is it will spill out, so what is the spill file contains. All these things will be clarified tomorrow. Clear? I think yeah, I can get the configuration here now. I can get the configuration for that when your combiner will be merged. Yep, this one. Min and num spill files combine. Madhu, are you able to see my screen now? The by default is 3. The min dot num dot spill for combine is 3. That's what I'm checking. It is not there in the Hadoop 2. Maybe they have might have hard coded in those hard coded in the core, you can see here during the merge, if amount of the files being merged in the more than or equal to this, then the combiner would be executed on top of the merge result before writing it to disk. Before writing into disk, that's what I was talking about. Your default the spills, the merge spills has to be 3. Then only your combiner will be launched. Otherwise, the combiner will not launch. So anyway, I'll be explaining these things tomorrow. Is that clear, guys? Any doubt? Madhu, Akash, Srini, Sunil, Srikanth,
No,
right? So that's it about the combiner and this. And so what we will be doing next? Next we will be discussing about the input formats, and we will discuss how many type of input formats are there and how many type of output formats are there. Then we will be discussing something called distributed cache. The distributed cache is nothing but joining for the two datasets joining. Then we will be discussing about secondary sort. There is something called secondary sort. After that we will be discussing compressions. Then we will complete the MapReduce. We can complete the MapReduce. Hardly the MapReduce will be another 1 2 3 4 uh, 1 2 3, I think mid of next week. Hardly mid of next week. By next Wednesday or by next Tuesday we'll be completing the things, and freshly we'll start a hive with the detail. Okay, by the time guys, I would recommend you guys to go through by the time, please everyone do a setup of go through hive and MySQL setup and use this document for the setup. Hive and MySQL setup. Okay, I'll update this document today with some more changes, and everyone please do hive setup in your machines, then we will go with it. Yeah,
Okay.
thank you guys, thanks for your time, have a great day.